given a recurrence relation here and a starting term. So t1 is 13. Now what we can do is substitute n equals 1 in. So t2 is going to equal a half t1 if t1 is even, which it's not. So instead I put n equals 1 into this one, t2 is 3t1 plus 1 if t1 is odd. It is. So I'm going to times through by 3, 39, and add 1, we get 40. And then I can then repeat the process. I'm just going to put n equals 2 in. So t3 would equal a half t2 if t2 is even, which it is. But basically, I'm just halving it if it's even, times in by 3 and adding 1 if it's odd. I can very quickly now start writing these down. 10, 5, right, now it's odd. I need to times by 3 and add 1, so that's going to take me to 16, 8, 4, 2, 1. And now it's odd again. I times by 3 and add 1, and I'm back to 4. And then I'll be 2, 1, 4, 2, 1 again. So once I've got to this point, it's going to repeat. And I can use that now to help me find T 2008. Now let's just imagine we were finding T12. Then I can see that I've got 7 like this. So I could do 12 minus 7, which is 5, and then it would be the fifth one in my repeating sequence. So I could then, well, I could minus 3 in this case to give me 2, and it's going to be the second one in my repeating sequence. So I can see that T12 would actually equal 2. I'm going to use that kind of approach for this part as well. So I've got 2008 terms, but I'm going to minus 7 to get basically ignore these 2001. And now I want to find the 201st term in this little sequence of repeating threes. And I can actually see that 3 is going to go into 2001. So if it's a multiple of 3, it's going to be a 1. Because I've kind of relabeled it now. So this is like T1, T2, T3 after I've minus the 7. So I want the 2001st term. It's a multiple of 3, so I can see it's going to be a 1. You can, of course, do 3's into 2001 if you want. You'll get a whole number, but we don't even need to do that. So that's a really good way of doing it. Yes, every time just subtract the 7, because we're then almost constructing a new sequence that is 421, 421, and finding out where we are in that sequence. If we happen to get something that was 1 more than a multiple of 3, then it would be a 4, because we'd be back to the very beginning. Anyway, answer is 1.